Which type of graph of a frequency distribution is the correct choice for presenting nominal data? Now, it's either going to be A, a histogram, B, a polygon, C, either a histogram or polygon, or D, a bar graph. Okay, so we have to have a look at what nominal data is. So if I did a survey and I asked people, what's your favorite pet? And people said cat. Somebody said a dog. And then two other people also said dog. And then finally somebody said turtle. This is nominal data. Nominal data is made up of categories that people fit into. So there's a couple of cat lovers here, and then these people prefer dogs, and this one person likes to have a turtle the best. So there's nothing numerical, there's nothing measured or counted when it comes to this data. And so they're asking what sort of a graph is the correct choice for presenting the frequency distribution that we would make out of this. Now the frequency distribution that we would make out of this would look like this. It would be that we've got pet, or we just call this X, and that's cat, dog, and turtle. And our frequencies are 2, 3, and 1. So how are we going to graph this? Well, the answer is that only a bar graph is the appropriate choice. We can't choose histogram, we can't choose polygon. And so it's going to end up looking like this. We're going to have cat, dog, turtle, and a bar graph really looks a lot like a histogram, except for one key difference. These are my frequencies. That difference is that we have to make sure that when we're plotting these, we leave spaces in between the categories. So dog goes up to 3, and turtle is just 1. This is different from a histogram or polygon, where the whole point of one of those sorts of graphs, let's say we've got a histogram. Now a histogram deals with things that are numerically counted or measured. So let's say we ask people, how many pets do you have in your home? So 0, 1, 2, 3, 4, 5. And it's going to look something like this. Maybe you've got this kind of data. All right, so this is what a histogram would look like. Notice that there's no gaps in here. Why are there no gaps? And why do we have to have gaps over here? Well, the data here is in order, and the order is important. As we go from 0 to 1, you go from having no pets to having 1 pet, and then here's 1 additional pet added in, and then 1 more, and 1 more, and 1 more. By having a graph where there's no gaps, it forces our eye to look from side to side and take in the kind of trend that you see as you move lower in the scale or higher in the scale. You can see that the number of pets in a home increases till you get to about 2, and then it starts to drop back off again. We don't want to do the same sort of thing over here, even though you can kind of imagine that sort of a shape. We're separating it visually so that we don't make the mistake of thinking that things are growing and then falling, because there's no reason that cat has to come first. I think I sort of accidentally put these into alphabetical order, but they don't need to be. It could be that we could have decided to group these in order of size. So starting from the smallest pets up to a larger cat and then a dog, and we would have something that looks like this. And it appears to be growing if we were thinking about it like that, but we put the gaps in so that we don't think side to side. We really just want to see how tall are these categories in relation to each other. This graph shows us that dogs are the most preferred pet in our sample, and that's all that we're supposed to be looking at. We're not supposed to be looking at growing and falling and extreme results in the ends. That's for histograms. Polygons are the same. Polygons are effectively just a histogram, but you just use dots instead of using bars. So you would have dots that you're going to connect. So we would have something that looks like this. Again, you can see that this shows us the kind of rise and fall that is important to be expressing or to be highlighting when you're dealing with actual numerical data. which we're not when we're dealing with nominal data. So a bar graph is the only choice.